What if I told you the modern world, the hospitals saving lives, the internet connecting us, the steel skeletons of our cities, and the fertilizers feeding billions, runs on the very thing we are told to despise: oil, natural gas, coal. For over a century, these fossil fuels have powered the greatest vertical leap in human prosperity ever recorded in history. Yet today, within the gilded halls of power and across global institutions, hydrocarbons are no longer treated as the essential tools of civilization, but as moral crimes. Is this actual science? Is it sound economics? Or is it simply ideology dressed up as inevitability? In this video, we examine the counter-narrative. We look at how leaders like Donald Trump are reframing the climate debate, not by denying physics, but by demanding a return to hard-nosed realism. This is not a story about rejecting climate science. This is a story about rejecting economic self-destruction. Modern civilization is, at its core, a thermodynamic machine. Energy is not a side issue. Energy is the economy. Nearly everything humans rely on, from the concrete under your feet to the chemotherapy in our hospitals, depends on dense, reliable, dispatchable energy. Fossil fuels today still supply roughly 80% of global primary energy. That number has barely changed in 30 years. Why? Because hydrocarbons are uniquely powerful. They are energy-dense, transportable, scalable, reliable in all weather, and deeply embedded in industrial chemistry. Wind and solar generate electricity intermittently, but oil builds the wind turbine. Natural gas produces the steel. Coal fires the cement kiln. Petrochemicals create the solar panels' polymers. This isn't ideology. It is industrial physics. Remove fossil fuels too quickly, and modern living standards collapse. That is not alarmism. That is arithmetic. In recent years, countries that aggressively pursued rapid decarbonization have faced painful consequences. Look at Germany. After shutting down nuclear plants and doubling down on renewables, energy prices soared, and industrial giants warned of relocation. Chemical manufacturers, the backbone of Europe's industrial base, began cutting production. In the United Kingdom, households experienced historic heating cost spikes. In Canada, carbon taxes became a flashpoint as cost of living pressures intensified. Now, are renewables the villain? No. But timing, scale, and grid physics matter. Electric grids must balance supply and demand in real time. When intermittent sources dominate without sufficient storage, volatility increases. Storage at national scale remains extraordinarily expensive. And here's the nuance rarely explained. Net zero modeling assumes massive grid expansion and rare earth mineral extraction. It assumes battery breakthroughs at lower cost, political stability across supply chains, and coordinated global compliance. That's not impossible, but it is not guaranteed. And when politicians treat scenarios as certainties, households pay the difference. The global climate discussion is heavily influenced by institutions like the IPCC. The IPCC produces massive assessment reports filled with ranges, confidence intervals, and scenario-based modeling. Buried within those pages are caveats. Climate sensitivity spans ranges. Feedback loops remain uncertain. Extreme scenarios assume high emissions trajectories that may not materialize. But what reaches the public? Executive summaries, media simplifications, worst-case projections framed as base-case futures. There is a difference between high-end scenario under specific assumptions and "this will happen." Scientific modeling is not prophecy. Climate models are extraordinarily complex. but they rely on assumptions about population growth, energy use, and technology adoption over decades. History teaches humility. Remember peak oil predictions in the 1970s? Technology changed the equation: hydraulic fracturing, horizontal drilling. Energy abundance returned. Which brings us to a critical turning point. Under President Trump's leadership, energy policy was reframed around three pillars: energy security, affordability, industrial strength. Rather than demonizing fossil fuels, the administration argued for continued production alongside innovation. Energy executives have publicly challenged what they see as overly optimistic transition timelines promoted by organizations such as the International Energy Agency. Critics argue those projections underestimate developing world energy demand growth, petrochemical expansion, and aviation dependence. In response to sustained pressure, the IEA has increasingly emphasized that stated policy scenarios differ dramatically from net zero pathways. That distinction matters, because stated policy trajectories, what countries are actually doing, show fossil fuel demand persisting for decades. That is not climate denial. That is empirical observation. Over 700 million people still lack reliable electricity. Billions seek refrigeration, transportation, clean water, and air conditioning in warming climates. To tell them to forego affordable energy raises ethical questions. Energy poverty kills. Indoor air pollution from biomass kills. Heat without cooling kills. The moral equation is more complex than carbon molecules alone. A common-sense climate policy asks, how do we reduce emissions without freezing development? That likely means cleaner natural gas replacing coal. It means nuclear expansion, incremental innovation, carbon capture research, and grid modernization. Not overnight bans, not forced scarcity. Scientific institutions operate within incentive structures, as all human systems do. Research funding flows toward areas of perceived urgency. Media attention amplifies dramatic projections. Political leaders respond to public fear. This does not invalidate climate science, but it reminds us to be skeptical. Humans are not immune to consensus momentum. Healthy science requires debate, transparency about uncertainty, and openness to revising projections. Suppressing dissent from any direction weakens trust. Confidence grows when uncertainty is acknowledged, not hidden. Climate change is real. So are trade-offs. The real question is not, do we act? It is, how do we act without collapsing affordability? Energy transitions, which are actually energy additions and not transitions, historically take many decades. Wood to coal, coal to oil and gas, leading to diversified energy sources for countries. Each energy source largely added to the mix, but never replaced it. Perhaps the future isn't fossil fuels versus renewables. Perhaps it's realism versus romanticism. President Trump's climate realism argument is not that emissions don't matter. It's that prosperity matters too. Without prosperity, no environmental progress is sustainable. Because history shows, wealthier societies clean their environments. Poor societies struggle to survive. The debate is not between caring and not caring. It is between managed transition and mandated disruption. Between modeling assumptions and economic reality. Between aspiration and arithmetic. The world runs on energy, and energy policy runs on trade-offs. The question is simple. Will we choose realism, or will we choose rhetoric? If this gave you a clearer way to think about energy, then you already see something most people don't. Because the world is changing fast. Understanding what's really happening with climate and energy policies has never been more important. This channel is about cutting through the noise. No hype, no extremes. Just clear, grounded thinking about energy, climate, and the systems that shape our lives. If you value that kind of perspective, welcome aboard. Please take a moment to like and subscribe if this helped you see things differently. Please share and turn on notifications so you don't miss what's coming next. Because the next decade of energy decisions will shape everything. So the more we get people to understand the reality, the better for us all. See you in the next one, and stay well.